Good afternoon, class. Here's exam 4 review, covering Chapter 4, Application of Differentiation, Chapter 5, Integrals, 6.1, Areas between curves. Here's 5.5, the substitution rule continues. We've already started that. And now adding to that 6.1, areas between curves. So we discussed that the integral of f of g of x, g prime of x dx, where g of x represents the u, its derivative is g prime, and g prime times dx is du. It's the integral of f of u du. It's the substitution method, which is the reverse process of the chain. So having said that, how do we integrate when ln x is involved? That's a choice of you. As you know, the derivative of ln x is 1 over x. Therefore, du is 1 over x dx, or you can write dx over x. Both of them are absolutely fine. So we are going to rewrite this in a manner that it becomes clear what we are dealing with. So this is ln x to the second power times 1 over x dx, which means u squared du. Now that requires the power rule, 1/3 u cubed plus a constant. Replace the u with ln x, and bear in mind, ln x to the third power, that means ln x times itself 3 times. It's not ln of x cubed. So 1/3 ln x to the third power plus a constant. What happens when we are dealing with a rational expression or a fractional expression? First thing first, can we simplify, put it in lowest term? We must. If we cannot, normally the denominator is a choice of you. Notice the derivative of the bottom is the top. E to the power of x is itself, plus e to the power minus x is minus e to the power minus x. So if you choose u to be the bottom, the top times the x is the u. Therefore, it's the integral of, so if you put the dx next to the numerator, you're dealing with the integral of du over u, and that's a natural log. Reversing the substitution, ln of e to the power of x plus e to the power minus x plus a constant. Bear in mind, you have to have an absolute value, but in this case, we do know the expression is always positive. Therefore, you can lose the absolute values. All right, just reminding you how the substitution works for a definite integral. So first and foremost is x times 25 minus x squared to the power of 1/2. We are dealing with a couple of polynomials. 25 minus x squared is more complicated. That becomes the choice of u. As you know, the derivative is minus 2x, which makes du minus 2x dx. So we're going to rewrite this by moving the x next to the x. And as I've mentioned, in most texts, they simply solve for dx. I don't like to do that when a number is missing. As you notice, -2 is missing, and you can only do that to numbers. So you can plug in -2 and undo it with its reciprocal, -1/2. So this is -1/2, the integral of square root of u du. We're going to discuss the limits because the limits 3 and 4 pertain to the variable x, not u. We're going to come up with that shortly. So this is u to the power 1/2. Again, requires the power root. So -1/2 remains. 1 over 1/2 plus 1, u to the power of 1/2 plus 1. This is 3/2. Its reciprocal is 2/3. Times -1/2 makes it -1/3. Now, what about the limits? Let's go back to the original. Let's reverse the substitution. Let's go back to the original limits. That's one way to do it, and you can evaluate. Or if you plug in 3 here, 3 squared is 9. So 25 minus 9 is 16. If you plug in 4 here, 4 squared is 16. 25 minus 16 is 9. So we can work with those. Plug in. So I'm going to keep the -1/3 out, plug in 9, plug in 16, evaluate. 9 to the power of 3 halves means square root of 9 cubed, which is 3 cubed, 27. 16 to the power of 3 halves means square root of 16, which is 4. Cubed, 64. Their difference is negative 37, with negative 1/3 is positive 37/3. The integral of 0 to 1 ln of x plus 1 over x plus 1 dx, again, natural log is involved. That's a choice option. As you know, its derivative is 1 over x plus 1 times 1, or simply 1 over x plus 1, which makes du 1 over x plus 1 dx. Again, let's rewrite it so it becomes clear that we are dealing with the integral of u du, and as far as the lim, and the answer is, of course, 1/2 u squared. But what are the new limits? I plug in 0 here, I get ln 1, which is 0. I put 1 here, I get ln of 1 plus 1, or ln 2. So 0 doesn't do anything. You just plug in ln 2 and you get 1/2 ln 2 to the second power. This is an exact answer. And in calculus, we always come up with the exact answers, unless otherwise asked. What is the integral of negative 2 to 2x to the power of 6 plus 1 dx? This can be easily evaluated. However, let's go with a very interesting theory. Integral of symmetric functions, f is continuous on the closed interval of minus a to a. If f is an odd function, meaning f of minus x equals minus f of x, the integral of minus a to a f of x dx is 0. Even it can be easily proved, and you can see it from here. This side, this area cancels out this area because this is above and therefore positive. This is below the x-axis and therefore negative. On the other hand, if f is even, which means f of minus x equals f of x, even means symmetric with respect to the y-axis, odd means symmetric with respect to the origin. Then the integral of minus a to a f of x dx is the same as integral of 0 to a f of x dx times 2. If you notice, from 0 to a and from minus a to 0, they are identical. And why do we go with that? Because it's a lot easier to evaluate from 0 to a. So having said that, is this an odd or even function? And it may not be any of them, therefore that doesn't apply. We can see that it's an even function because f of minus x equals f of x. Okay, so if I plug in, just for the sake of argument, minus x, I get minus x to the power of 6 plus 1, which is x to the power of 6 plus 1. So that checks that it's an even function. So instead of evaluating from negative 2 to 2, I'm going to evaluate it from 0 to 2 and multiply it by 2, because it's easier that way. So this is obviously 1 over 7 x to the power of 7 plus x. Remember, we don't have a constant because it doesn't make any difference. It goes away. Now, if you were to evaluate this from negative 2 to 2, it would take a tad longer. But now from 0 to 2, 0 doesn't do anything. This is 1/7. 2 to the power of 7 is 128. This is 2. Because this is 7, 14 over 7. And therefore, 142 over 7. 2 times that, 284 over 7. What about the integral of tan x over 1 plus x squared plus x to the power of 4 dx from negative 1 to 1? This is 0. Why is that? Well, all you have to do, prove the function is an odd function. By the way, we don't have any tools yet to integrate that. So if I want to evaluate f of minus x, what happens? F of minus x, this becomes tan of minus x. 1 plus minus x quantity squared plus minus x quantity to the power of 4. The bottom doesn't change. This one becomes tan of minus x, which is minus tan of x. And believe it or not, we just proved that f of minus x equals minus f of x. F of x is an odd function. Therefore, this must be 0. When I evaluate these two, and I want you to see them side by side because they involve trigonometric functions, more specifically sine and cosine. When the argument is a function of the independent variable, happen to be x, any variable, then that is the choice of u. In this case, the argument x squared. As you know, the derivative is 2x, which makes the u 2x dx. Again, we're going to move the x so that it becomes clear that everything is in order except number 2 is missing. So again, in most texts, they solve for dx. I'm going to just put the 2 and undo it with 1/2 because a number is missing. So 1/2 sine u du. As you know, the derivative of sine is cosine, but the integral is negative cosine. The integral of sine is negative cosine. So minus 1/2 cosine u and a constant. Replace the u, minus 1/2 cosine of x squared plus c, and we are done. However, what happens when sine and cosine both are involved? Then the one which has the exponent is a choice of u, in this case sine x. As you know, the derivative is cosine, and the u becomes cosine x dx. So the one that has the exponent without the exponent becomes u. If both of them have exponents, then you have to use trigonometric identities. So you end up with either just one cosine, like cosine x, or one sine, because the derivative of sine is cosine. The derivative of cosine is negative sine. It's not a big deal that it's negative. So having said that, we are dealing with the integral of u squared du using the power rule, 1/3 u cubed plus a constant. Reversing the substitution gives us the idea. 1/3 sine cubed x plus a constant. So what if cosine has the exponent? So the integral of cosine to the power of 20x sine x dx, then cosine is a choice of u. And that means the derivative is negative sine x, which makes the u negative sine x dx. Now, this piece is missing a negative sign, otherwise would be okay. So you can put a negative in, negative out. So that takes care of the business. Please understand, -1 times -1 is +1, and we are fine. So we have minus the integral of u to the power of 20 du, which is using the power rule, -1/21, u to the power of 21 and a constant. Replace the u, -1/21 cosine to the power of 21x, and we add a constant. We are done. Application problem, breathing. We can model the rate of airflow into the lungs by the function f of t equals 1/2 sine of 2 power 5 t liters per second, where t is the time in seconds. Find the total amount of air inhaled in one cycle, known as the tidal volume, if the cycle lasts 5 seconds. Obviously, if it takes 5 seconds in and out, half of that would take for each case. Note the time for inhalation is half of the cycle, 5 halves. So it took 5, so 5 halves seconds. Total amount of air inhaled is the integral of 0 to 5 halves f of t dt. And of course, f of t is whatever they have given us, half of sine 2 power 5 t dt. So I want to work on this. And when we check this out, we notice the argument of sine is a function of the independent variable t. Therefore, the argument is a choice of u. As you can see, the derivative is 2 pi over 5, which makes du 2 pi over 5 dt. So I'm going to rewrite this. It becomes clear what we have, what we are missing. And this 1/2 is a number. You can keep it inside or outside. It makes no difference. I'm going to keep it outside. So we have the integral of 0 to 5 halves. I took the 1/2 out. Sine of 2 pi over 5t and dt. So what do I need? What is missing here? Because 2 pi over 5 is a number and it's missing, I can put it in. Its reciprocal 5 over 2 pi goes out. It's important to know the product must be 1, and it's more important to know that it's a number that you're dealing with. 2 pi over 5 is a number. So we have 5 over 4 pi sine u du, and we're going to figure out the new limits. Of course, this is 5 over 4 pi sine. Remember, the derivative is positive cosine. The integral is negative cosine u. What are the new limits? Let's find out. So if I put 0 here, that goes to 0. If I put 5 halves here, I get 2 pi over 5 times 5 halves, right? We replace the t. And obviously the answer is just pi. So those are the new limits. So minus, I'm going to put the negative out. It's easier to deal with it. Minus 5 over 4 pi. Cosine of the upper limit pi minus cosine of the lower limit 0. Cosine of pi is -1. Cosine of 0 is +1. So -1. This makes it -1. In other words, -2. Times -5. It's +10 over 4 pi or 5 over 2 pi. This is an exact answer, roughly 0.796, 0.80, depending upon how many decimals they ask you. This was liters per second. That was the rate. This must be in liters. Units are extremely important in applications. Let's integrate tan x dx. To do that, we are going to use trigonometric identities. We know tan is sine over cosine. Anytime you have a fractional format, after you simplify it, and this one can't be, then the choice of u is the denominator. As you know, the derivative is negative sine x, which makes du negative sine x dx. So let's rewrite this as this 1 over cosine times sine x dx. So everything is in order, except this negative sign is missing. So negative sign means -1. So put the negative in, negative out. That's all there is to it. So you put a negative sign in, negative sign out. That takes care of the business. So we have -1 over u du. As you know, again, we keep the negative out. This is a natural law. And replace the u with cosine minus ln of absolute value of cosine x plus a constant. So as far as logarithmic properties are concerned, I can put this as a -1 and make it an exponent. So this is ln of cosine x to the power of -1. Cosine x to the power of -1 means 1 over cosine x. Means secant x. So ln of absolute value of secant x plus a constant is the final answer. Substitution method, fairly nice and easy. Let's go over 6.1, the area of the region between the two curves. So we have two curves. The one at top is f of x, the one at the bottom is g of x. And we want to evaluate the integral between the two from a to b. Let f and g be continuous functions with f larger than or equal to g. That means it's at top of it. Over the closed interval of a to b. Then the area of the region between the two curves from x equals a to x equals b is, and I'm not going to remind you that the area we said it's the summation with the Riemann sum, the limit as n approaches infinity of the summation I going from 1 to n of f of x by delta x, or the definite integral of a to b f of x dx, where delta x is b minus a over n, x of y is a plus I delta x, and we use this definite integral anytime the function is a positive function. It represents the area under the curve. So in this case, this is area of the region between f and g. F is at top of g from a to b. This one is the area of the region under the first function f of x, this one. This red one is the area of the region under g of x. So the green minus the red becomes what we want. The integral of a to b f of x minus g of x dx is the integral of a to b f of x dx minus the integral of g of x from a to b dx. So we use this one. So in essence, we are just showing the proof. That's how it works. Okay. So what is the procedure? The area of the region between two curves process. Number one, graph the two functions. Number two, find the points of intersection by setting f of x equals g of x and solve. Evaluate the integral from where you must points of intersection. So this is an increment, okay, of area looking like a rectangular shape. It has a height and it has a width. The width is dh and the height is whatever it might be. In this case would be the y of the top minus the y of the bottom. Of course, this width is extremely small, everybody. So the area of a typical rectangle is y of the t, that means top, minus y of the b, that means bottom, times delta x. In this case, dh, I'm going to go with dh because if you sweep this across the x-axis, that means delta x. But if you have to go up and down, it's dy or delta y. And the equation becomes dA, an increment of the area, is h times dh. The area A to be h dh. H, you replace it with the proper value, which is y of the top minus y of the bottom. And dh, as I mentioned, in this case is dx, because it's you sweep it across the x-axis. Or if you have to go from right to left to right, then x of the right minus x of the left. So that depends, okay? It's very important to know which one is the case and what you are going to write. We are going to look at some examples. So the integral of a to b f of x minus g of x times dx. Find the area of the region bounded by y equals 2x squared minus 3x plus 2. I hope you realize it's a parabola and everybody can graph it. X equals minus b over 2a represents the location of the vertex and so on. I'm going to assume no one has any problem graphing this. You graph it and we want the area okay, which is bounded by this function and the x-axis, and x equals 0, that means the y-axis, and x equals 2. In other words, we want this area. This is the shaded region we are interested in. So an increment of an area, and that's the vertex, is this, which is this distance is height, y of the top minus the y of the bottom, and this distance is the width. So dA, an increment of an area. Remember, the width is extremely small, so that's why you can think of it as a rectangle, is the height times the h. Now, the height equals the y of the top, which comes from the curve f, minus the y of the bottom that comes from the x-axis, and it's 0. So the top function is the curve, the bottom is just nothing, minus 0. But you have to be very careful with that. So just evaluate the area, replace the h with that, and the h is the x, because think about this. If you look at various, let me just erase my work. Locations, it moves, okay, from here. So that's a piece, that's another piece, and so forth. That's why I hope you see that you're moving this across the x-axis. So it's dx. And that's easy. We know how to evaluate that. And this becomes 2/3 x cubed minus 3/2 x squared plus 2x. Now 0 doesn't do anything. You plug in 2. So if I plug in 2, I get 8 times 2, 16/3. If I plug in 2, I get 4 times 3, 12 divided by 2 is 6 minus 6. And I get a 4. This is negative 2. Because this is 3. So times 3. 10/3. Evaluation is up to you. It should be fairly easy. Everybody knows how to evaluate. Find the area of the region bounded by the two functions. F of x is 2 minus x squared. G of x equals x. So what do we do? First, we graph it. This is a parabola, minus x squared going down, 2 shifts up. This is g of x equals x, a line through the origin. So I'm going to assume no one has any problem graphing it. Now, an increment of the area is this. Just think about this strip of rectangle. You can move it this way, and it covers the entire area. By the way, if you draw it this way, for here is not a problem, but for here, the right and left, they both use the same curve. That's why you can't do that. So we have that, and now we are going to set the two functions equal first. We want to find points of intersection. So we are going to, this is negative. Let's move it to the other side. X squared plus x minus 2. Let's factor. You want two numbers. The product is negative 2. The sum is positive 1. 2 and negative 1. So we get either x is negative 2 or positive 1. And obviously, the easiest way would be to take it to this one. You really have to try it with both. So this means x is negative 2, so is y. This one, x is 1, so is 1. So we have the following two pairs. Now, I use this one to evaluate it, but you can put it into this one, and you see, for example, 2 minus negative 2 quantities with positive 4. 2 minus 4 is negative 2. You really have to check with both of them. So having said that, this is the height, which is f minus g. So a typical rectangle has the area height, which is y of the top. This is y of the top minus y of the bottom, and times dx, because the width, okay, we move it along the x-axis, is dx. So just plug in y of the top is coming from the curve or the parabola 2 minus x squared, and the bottom comes from the line, and we have the integral of this from now as from the x coordinates -2 to 1. By the way, one may think, okay, it doesn't matter, the y is the same, but it happened to be the same. You are evaluating from the x coordinate of the first point to the x coordinate of the second point. Okay, again, the y coordinate happened to be the same, but what if they are different? Okay, so we don't want to mix them up. So this gives you 2x minus 1/3 x cubed minus 1/2 x squared from -2 to 1. You plug in 1, you plug in -2. And I'm going to leave it for you to verify the answer is 9/2. And we are done. Again, I highly recommend you guys verify that. It's important to make sure you have it right. All right, so what do we want to do here? We want to find the area of the region bounded by the graphs of x equals 3 minus y squared and y equals x minus 1. Y equals x minus 1 is a line, okay? You come up with a couple of pairs, you find it. This is a parabola, and minus y squared means opens to the left. And I'm going to assume everybody knows this is the graph. Now, notice x is 3 minus y squared. So in this case, we can solve for x, and it becomes y plus 1, just in case. And of course, as far as graphing is concerned, it doesn't matter here or here. You come up with a couple of pairs. X is 0, find y is 0, find x. And you have the line, and it basically is the region in between. So this shaded region. So we need to find points of intersection first and foremost. So we are going to set them equal. So 3 minus y squared, okay, we're going to set x equal to x. 3 minus y squared is y plus 1. Please pay attention that this is x, this is x, so this side is equal to this side. And so if I move this to the other side, I get y squared plus y minus 2. And so what we have here is y minus 1 times y plus 2. So y is either 1 or -2. So if y is 1, x is 2. If y is 1, x is 2. If y is -2, x is -1. So you're going to, the easiest way is to erase my board first. Put this 2 into this easy line. And, okay, you can put it into this one and check it with this one. So we have the pairs, and notice this function, the curve, is completely on the right side of this function, the line. Okay, if you go a rectangular strip like that, here and here is fine, here is fine. When you get here, the top and the bottom belong to the same curve. If I want to make sure we understand what I'm saying. Over here is fine if I draw this. But over here, it's not fine because the top and the bottom come from the same curve. So instead, we are going to look at dA in this manner. An increment of the area is this one. And this height is x of this one minus x of this one. We call it x of the right minus x of the left. And this is going to move up and down. It's going to sweep up and down. So dy in order to cover that. So x of the right comes from the curve and is 3 minus y squared. X of the left comes from the line and it's y plus 1. So this is g minus f, 3 minus y squared minus y plus 1 dy. So the idea is to understand how this works and the rest becomes fairly easy, everybody. So having said that, the area is the integral of this one and from the y coordinate -2 to the y coordinate +1. So pay attention to how we choose those. So we choose, because this is a function of y, we choose the y coordinates. Let's put this in order. I'm going to put this one first, minus y squared minus y plus 2. I'm going to find this -1/3 y cubed minus 1/2 y squared plus 2y. And again, from -2 to 1, I'll leave it for you to evaluate it and show that it's equal to 9/2, everybody. So that's pretty straightforward. Find the area of the region that is bounded by the graphs of f of x equals 2x plus 1. This is a line, and g of x equals x squared plus 1. This is a parabola that opens up. So first thing first, we need to graph the functions, and I'm assuming no one has any problem graphing. Then we have to find points of intersection. So set f of x equals g of x and solve. So set these two equal. We can get rid of that, move the 2x, factor the x out. And x is either 0 or 2. And so when it's 0, you can go as 0 here, you get 1. And when it's 2, 2 times 2, 4 plus 1 is 5. So it's easily understood. I want to evaluate the integral. So if you want to evaluate the integral, you need an increment of an area. So clearly the line is above the curve. So this is y of the top. This is y of the bottom. So an increment of the area is dA equals y of the top minus y of the bottom times dx, because this little blue strip should move left and right, creating dx. So this is dx. The height is y of the top, which is from the function f of x, the bottom from g of x, so f minus g. And so f is 2x plus 1 minus g is x squared plus 1. And so the integral of this, now because we are dealing with dx, then the limits comes from the x coordinate 0, so from 0, and then the next x coordinate is 2, from 0 to 2. Now, I hope you see these two cancel each other. We get 2x minus x squared. And this is x squared minus 1/3 x cubed from 0 to 2. As easy, 0 doesn't do anything. This one is 2 squared minus 2 cubed minus 3, and that is 4. This is minus 8/3. 4 times 3, 12. Minus 8 is 4/3. So it's easily evaluated. Now, what's interesting about this, we can do the second method as follows, because you may notice that the line is completely above the curve on the one hand. On the other hand, the curve is completely on the right side of the line. So you could use it that way. And so this distance, okay? So this is x up the right, this is x up the left, okay? So in other words, g minus f. Now, of course, we have to be very careful because we need to solve for y. So it's important to understand that this one, f of x y, is 2x plus 1. This one is y equals x squared plus 1. And each one, now that we put it as y, we are going to solve for x. So what happens here? You move this. So 2x is y minus 1. So x is half of that. And this one, you move it this way. X squared is y minus 1. X is square root of y minus 1. By the way, I hope you remember that x is plus minus the square root of y minus 1. The parabola, the graph is that the right side is this, and the left side is this. This is x equals that. The left side, x equals minus square root of y minus 1. This is just college algebra we discussed already. So let me erase my work. And so we are going to go with the integral of a to b x sub right minus x sub left dy. I didn't erase it. Okay. So this on the right side is the curve, which is this one, square root of y minus 1, minus. On the left side is the line, half of y minus 1, and then dy. And the integral, now, because it's dy, you're going to go with the y coordinates. The first y coordinate is 1. The second one is 5. So from 1 to 5. And now I want to evaluate this and then evaluate this, because this actually requires substitution. Let's quickly separate them. So just concentrate on this one. And to do so, we're going to say y minus 1 is something. For example, u, du is dy. So we're dealing with u to the power of 1/2, which is 1/1/2 plus 1, u to the power of 1/2 plus 1. And as far as the limits are concerned, let's figure out the new limits. So if I put 1 here, I get 0. If I put 5 here, I get 4. So from 0 to 4. So of course, 0 doesn't do anything. You put the 4. And square root of 4 is 2. Cubed is 8 times 2, 16/3. Now let's work on the second piece. As you know, this is 1/2 y squared minus y. This 1/2 remains. 5 and 1 you plug in. what I did, I put the one half out. So it becomes 1/4. This is y squared minus 2y. It becomes easier. So this is 25 minus 10, and then plug in 1 minus 2. So 25 minus 10, 15. This is -1 with -1, 16 over 4, which is 4, which means the answer is the difference between the two. 16 thirds minus 4. 4 is 12 thirds, so it becomes 4 thirds, and that's exactly what we had in the previous page. Now, what is the purpose of this? There might be cases where you can do both ways, but normally one is easier than the other. As you noticed, the other method was easier. All right, we want to find the area of the region between these two curves, and I'm going to assume everybody can graph the functions easily. So what we want is this one and this one. In other words, we are interested in finding this. As you can see, the cube function is this one, the quadratic function is this one, so we're going to write next to them. And if you look at this piece, for example, the cube function is at top. If you look at this one, the parabola is at top. And that's why you want to be careful. So first, let's find points of intersection by setting them equal. So as we set them equal, everybody, these two are identical. We don't have to do anything. Cancel them. And then we bring this side. We factor the 3x out. So this means x is 0. This means x is negative or positive 2. So you can see the points of intersection. There are 3 points. -2. Now you're going to plug it into one of them, okay, to find the y coordinate. For example, if you put here -2 to the power of 2, you get positive 4 times -4. This -4 becomes -8. The rest of them, 0 is easy. And you plug in 2 and you get 0. So you have those 3 points. And now that you do, you want to evaluate the integral. To evaluate the integral, we are going to go with dh, y of the top minus y of the bottom. So let me see what. So y of the top for the first piece comes from the cube function. For the second piece, and the bottom comes from the parabola. For the second piece is the other way around. So for the first piece is f of x minus g of x. So we are going to put that in an absolute value sign when that happens, which means this one is f minus g. So we are going to evaluate 3x cubed minus 12x, okay? Remember, this is f minus g. And because this is the x, we are going to look at the x coordinates from -2 to 0. On the other hand, if you look at this one, is g minus f. Because it's the top, g minus f is the opposite of this one. G minus f is minus 3x cubed plus 12x. So the integral of that from 0 to 2. From 0 to 2. So that is really the point of this question. The rest is fairly easy. So here's what we do, everybody. 3/4 x to the power of 4 minus 6x squared from -2 to 0 plus -3/4 x to the power of 4 plus 6x squared from 0 to 2. I'm going to assume you can evaluate this. You can evaluate this. And the answer is 24. So the key being, you want to be very careful. You have to draw an increment of an area to see which one is at top, which one is at the bottom.